Okay, so we've got this scenario. This is coming in with a speed of ku. This is stationary. Afterwards, we're told the two speeds, but we're not told the directions. So we've actually got two options. They can either both carry on in the same direction, or in a moment we'll look at option 2 where they bounce off each other. So looking at option 1, conservation linear momentum, we get 4k mu plus 0, 4 mu plus 9 mu over 2. Okay, and from that we can cancel all the mu's. 4k equals 4 plus 9 over 2, so 4k equals 8.5, and that gives k equals 7. This is 17 over 2, 17 over 8. And the impact law, we've got speed of separation is E times the speed of approach. So that's got half u. We know k is 17 over 8. Cancel the u's, and we get E equals 4 over 17. Okay, now alternatively we could get the situation where they bounce off each other, so we're going to exactly the same process. The start is the same, the end we could have this option, so that is going with 3u over 2, but it bounces off still with a speed of u, but the opposite direction. Okay, so we do the conservation linear momentum again, and we get 4k mu equals 9 mu over 2, take away 4 mu. That gives us 4k equals a half. So therefore k is 1/8. And the impact law, speed of separation, so we've got u plus 3u over 2 equals k times the speed of approach, sorry, e times the, so ku times e. Okay, so we know k is 1/8, so this is 1 plus 1.5, this is 2.5 u equals 1/8 ue. So that gives E equals 2.5/8 is 20. This is impossible, since E is between 1 and 0. And so we can conclude, as there are only two options or two possibilities, we can say that k equals, first option, 17 over 8. Okay, we could also say that, this is what it says in the mark scheme, that if k was 1/8, then both particles would gain in kinetic energy. Right? If you work out the kinetic energy before and after for both, if k was 1/8, they both gain, okay, which is not possible. Alright, now we've got to find the total kinetic energy lost in the collision. So let's move this up. Kinetic energy lost is energy at the beginning, half 4m ku squared. Take away the two kinetic energies afterwards. We can take a factor of mu squared out, and we're left with 2k squared. Take 2, take away 27/8. We know what k is, so we can plug that in, and we get 117/32 mu squared.